Okay, we're going to revisit some of these, but some of these are going to get a little tougher now. A hair salon receives a shipment of 84 bottles of hair conditioner to use and sell to customers. The two types of conditioners are A and B. Type A costs $6.50 per bottle, and Type B costs $8.25 per bottle. The hair salon's invoice for the conditioner is $588. Find how many Type A bottles and Type B bottles were bought. Okay, so we have 3 units, Type A, Type B, and dollars, so that makes a system. Dollars are a function of the bottles you buy, but you're buying 2 types, A and B, and they cost different amounts. So that's a system of 3 units. Okay, so you make a system grid. You put together first, and then the 2 things you're buying together are the Type A bottles and the Type B bottles. Then, how many units, that'll always be used. Then, per unit, and it's going to be dollars per unit. And then total, and it's going to be dollars total. Okay, fill in your total amount together, and that's 588. Okay, if you know what goes there, you don't need this, the 588. Okay, that's not needed. Okay, or excuse me, this isn't needed. This middle box will not be used. Okay, then how many units? Well, remember, these are dollars amounts. How many units? We know there's 84 together. So then we use 2 variables. You can use A plus B or X plus Y, whatever. Okay, equals 84, and that's an equation we're going to use. Then to find the second equation, I put in my cost amounts. So Type A is 6.50 and Type B is 8.25. So then find these products. You take how many units, X, times 6.50, and then Y times 8.25. Well, you're not able to find the actual product because you don't have X, so you write the expression 6.50X and 8.25Y respectively. Okay, then you stack them into a system using the elimination method. X plus Y equals 84. 6.50X plus 8.25Y equals 588. Okay, now you got to apply elimination. You need to do a multiplication step because these don't match. So times 6.50 and times 1. Okay, so it's going to be 6.50X plus 6.50Y, and then 6.50 times 84. I believe is 542, or 546, sorry. Good thing I put that. Okay, then the bottom you get 6.50X plus 8.25Y equals 588. Okay, now you apply your elimination. Okay, now these have to add to 0, which can happen if you make it negative. Then negative, negative. So you add here negative 1.75y. Then you add these, you get negative 42. Now you need to divide by the negative 1.75. And that equals 24 whole. So Y is 24, 24 Type B bottles. Now you can put 24 into one of the equations, or you can use some common sense. What plus 24 is 84? Well, how about you take 84 minus 24 and see it's 60. Okay, 60 is your A bottle. 60 plus 24 is 84. Okay, and if I take the 60 that I purchased times $6.50 plus the 24 that I purchased times 8.25, it equals 588. Okay, next problem. The manager of a store that specializes in selling tea decides to experiment with a new blend. She'll mix some Earl Grey tea that sells for $5 per pound with some orange pekoe tea that sells for $3 per pound to get 100 pounds of the new blend. If all this is sold, they're going to make a total of $450. How many pounds of each tea is required? So dollars is a function of the pounds of tea, okay? So you have but you have Earl Grey and orange pekoe. So again, that calls for a system to be utilized. Okay, so together, and you're buying in the Earl Grey and the Orange Pekoe. Now when you buy this, this comes in pounds, okay? Last one came in bottles. When we buy these, they come by the pounds. You see when you see per pound, okay? Then, how many units per unit and total. Then the dollars is a function of the pounds, so dollars per total, dollars per unit, not dollars here. So your total cost we have is $4.50. So if you have the total cost, you won't be needing that, okay? How many units? You see 100 pounds, okay? So that's together, and then that would be X plus Y, or E plus P. You don't want to use O because that looks like a zero. You don't use O as a variable. Okay, then the cost per unit. Well, Earl Grey costs $5 and the Orange Pekoe costs $3. So to find these amounts, we take the X times 5 and the Y times 3. So are we able to find the actual product? No, it's 5X and 3Y. Now stack them, okay? So X plus Y equals 100, 5X plus 3Y equals 450. Okay, you got to use your elimination method. You're going to multiply the top by 5 and the bottom by 1. So 5X plus 5Y equals 500. And on bottom, 5X plus 3Y equals 450. Okay. Just put a negative there, so that adds to 0, which you're allowed to do as long as you make the rest of it. It's really you're multiplying the whole bottom equation by -1 when you do that. So that's 2Y, and that's 50. So then you divide by 2, and Y would equal 25. So 25 pounds of the Orange Pekoe tea. Now, how many pounds of the Earl Grey? Well, X plus the 25 equals 100, so we could take 100 minus 25, and that'd be 75. You see, 75 plus 25 equals 200. Okay, now things are going to get a little harder. Well, not harder, just different. A coffee manufacturer wants to market a new blend of coffee that sells for $3.90 per pound by mixing cinnamon flavor, which normally sells for $2.75 per pound. That's when it's sold by itself. And vanilla flavor that sells for $5 per pound. Again, that's when it's sold by itself. They're going to mix them together and sell them for $3.90 per pound. The total weight of the new blend is 100 pounds. What amounts of each type of coffee should be blended? Okay. So again, together, and what are we blending together? The cinnamon coffee, which comes in the pounds, the vanilla coffee, which comes by the pounds, okay, and then how many units per unit and total. So money over per unit, money over total. Okay, what's your money total? You don't have one, do you? These are all per unit amounts, okay? So I put an equals, but I leave that empty. That means I don't cross this out. I need to put something there, okay? Now, about how many units, you have 100 pounds, so that's together of the new blend after you've done putting them together, and then this would be X plus Y, or you can go C plus V. Well, cost per unit, there's 3 costs per units. Now, you want to read the problem. It costs $3.90 per pound by mixing, so that means that's together when they mix them. Okay, so 3.90. This plus this is not this. That middle row, it's not an addition thing. Top row is, bottom row is, but not this. Okay, and then cinnamon sells for $2.75 per pound, and then the vanilla sells for $5 per pound. You got to really read that. So now we take X times 2.75, and that's 2.75X. And then Y times 5, and then we take 100 times 3.90. So 2.75X plus, that's 5Y, Okay, equals what? Well, what's 100 times 3.90? That's 390. So we have our system here and here. We just had to work a little bit to get our total. Not very hard, but so x plus y equals 100, and then $2.75 times x plus 5y equals 390. Now you apply your elimination, you get some weird answers on this one. So I multiply by 275 on top, and I will multiply by 1 on the bottom. So we have $2.75 x plus 2.75 y, and then 275. The bottom would just stay the same. Okay, line up them columns. 0x as long as you make the 5y negative and the 390 negative. So this is going to be negative 2.25y, and this is going to be negative 115. So you're dividing negative by a negative, so that's good. But what's kind of annoying is this division's kind of weird. Negative 115 divided by negative 2.25, just second PRB that, and you get 51 and 1/9. So in your y, you can have 51 and 1/9 of a pound. You'd have 51 whole pounds, then 1/9 of another pound. So 51 and 1/9. Now to find the cinnamon, what plus this is 100? Well, you take 100 minus 51 and 1/9. And that's just 48 and 8/9. Which makes sense. 48 plus 51 would be 99, and then 8/9 plus 1/9 makes a full pound to get to 100. So 48 and 8/9. Okay, next one. You've seen this before. An adult pass for a county fair costs $2 more than a children's pass. When 378 adult and 214 children's passes were sold, the total revenue is $2,384. Find the cost of an adult pass, cost of a children's pass. So again, it's another system we need to make. There's passes, but there's an adults and children's. Okay, so you have together, you have how many units, you have the per unit, you have total. Okay. Okay, so adults and children are what you're purchasing together, passes actually. Okay. So the dollars are then the function of the passes sold. Dollars, so then equals, and it's $2,384. Okay, now how many units? Remember, this is for money amounts. Okay, so 378 adult and 214 children. You can add those. That'd be 592. By the way, we don't need this. When we have our total, we don't need that middle. Now, the only other thing I see for the info here is that the fact that adult passes cost $2 more than children's passes. Now, 2 more means plus 2. Okay, so one of the unknowns has a plus 2. It would be the adults because they're more. You don't just put 2 in. Okay, like it could be 8 and 6. It could be 2 and 4, but we don't know that. Okay, so when I put that plus, I write it only in terms of x. So only x. I don't need y, and there's only going to be one equation that I use. So this would be x plus 2, and this would be x, or whatever variable you want to use. Now when you multiply, you got to remember x plus 2 is an entire quantity. So we need to take 378 multiplied by the quantity x plus 2, and then 214 times x. So we distribute 378 to x and 378 to 2. So it's going to be 378x and then 756. And that's what you put in that box in. That remains a, and that's 214x. Okay, you only needed one equation. It's all in terms of the same variables, so you only need one. You don't need to stack 2 of them up. That's when you don't write it in terms of the same variable. Okay, so the x's are on the same side, so we add those. It's going to be 592x plus 756 equals 2384. So we minus 756, and that's 1,628. And then we divide both sides by 592, and that's 2.75. Okay. So here's your solo x, that's 2.75. That's your children's passes. Now your adult passes is just 2.75 plus 2, which would be $4.75. Okay, last problem here. This one's going to be a little bit challenging to set up. Okay. Two teams in a game combined for 897 yards of total offense. Team A ran 41 plays, while Team B ran 45 plays. Team A averaged 3 yards more per play than Team B. Find the yards averaged by each team per play. Okay. All right, we don't really have money here. That's what makes it kind of confusing. Okay. I'm going to extend these underlines so you see Team A plays and then Team B play, the plays that they run. Okay, so the yards is your total instead of the money. It's like yards replaces the money. Okay, and then yards are a function of the plays run by Team B and the plays run by Team A. So again, it's a system. So together. So it's Team A and Team B, the plays that they run. So it's plays that Team A ran and plays that Team B ran. Okay. Then how many units per unit and total. So instead of using money and money, it's going to be yards. I mean, the total amount you're given is in the quantity of yards. And the yards total we know then is 897. So again, this is not needed when I know the total. Okay, so how many units? Remember, if you're confused about what you put where because you don't see that almighty dollar sign, just put yards, just put YD, YD. This is for not YD. All right, so 41 plays. The quantity 41 belongs here. It's not yards. It's how many plays that Team A ran, 41. And then 45 is how many Team B ran. So then we add those together, it's 86. Okay, then the only thing we really see about the yards per unit, the yards per play, is that Team A was 3 yards more per play than Team B. So I put a +3 in Team A's column. But I don't really, again, I only need X. I write this only in terms of X. So that means there's only going to be one equation that I really need to get down here. So X plus 3 and X. So that's a quantity. So I'll take 41 times the quantity X plus 3 and then 45 times X. So it's 41X and then 41 times 3 is 123. And then this would just be 45x. So it's 41x plus 123, and here's just 45x. So all I need is that bottom equation to solve this. So 41x plus 123 plus 45x equals 897. Okay, so I V up my x's. So it's going to be 86x plus 123 equals 897. Okay, so I subtract 123 from both sides. That's going to be 774. And then I divide each side of the equation by 86. So 774 divided by 86 gives me 9. Okay, so Team B had 9 yards per play, but Team A is even higher, 12. That's good offense.